Hello, AP Stats students. Sorry I haven't seen you recently. I really hope to be back as soon as possible. I got a question about PDF histograms, so I figured I'd take some time to go over it with you guys. We're going to do it using this bullseye problem. Now, we know that probability of hitting the bullseye is 80%, and we are dealing with 6 arrows. Now, the first question we have to deal with here is, what is x? And x is going to be the number of bullseyes hit. That's what we're dealing with here. Okay. So now we're going to take this a step further. We're going to construct a table, and the table is going to be the key to putting together our histogram. So I'm going to make it 2 rows. On top is going to I'm going to use x, which is going to be the number of hits out of the 6, and then I'm going to put my probability down here. So I have 6 arrows, so I have 6 possibilities. I can hit it 0 times, I can hit it 1 time, I can hit it twice, 3 times, 4 times, 5 times, and 6 times. Since I'm only shooting it 6 times, that is my maximum. Okay, so I want to calculate the probability of hitting the bullseye 0 times first. So I'm going to use my binom PDF function, because remember, order doesn't matter here. If order didn't matter, then I could use geometric probability. So I punch it in. I'm going to do binom PDF. I want 6 times. There's a 0.8 probability. I'm looking at the probability of hitting it 0 times. When I get that, I'm going to get a really small value. It's going to be 6.4 times 10 to the negative 5th power. So that means if I'm an 80% bullseye hitter with my bow and arrow, chances of me not hitting it at all 6 times is going to be incredibly low. So it's actually going to be very close to 0. So I'm just going to put this little symbol here, meaning that I'm not giving exact probabilities, but I'm giving something close. So my probability of not hitting one is going to be very, very close to 0. So I'm just going to put 0 there. So then I'm going to do binom PDF to figure out probability of me only hitting it once. So I'm going to use the same functions here. I'm going to try it 6 times, still a 0.8 probability, and I'm doing it once. When I plug that in, I'm going to get a small number, 0.0015. That's what you should be getting too. So in this box here, I'm going to put 0.0015. And I would proceed to do that for every possibility here. I'm going to do binom PDF, 6.8, and then I'm going to plug in how many times I hit that bullseye. So for twice, 3 times, 4 times, 5 times, and 6 times. And instead of walking through it every single time, I'll just show you what I got. And hopefully this is what you get. 0.0154. So it's probability still pretty low of me only hitting it twice out of the 6 times. And you're going to notice the probability goes up as I go along. That's because if I'm a pretty good bullseye hitter, chances are if I'm hitting it 8% of the time, these are the values I should be expecting. Should be expecting to hit it quite a few times. 3, 2, and last but not least, 0.2621. Alright, so again, all I did was I used binom PDF, typed in 6.8, and then the number of trials, and then I got all these probabilities here. Now, for a probability histogram, this is pretty easy now, because all I have to do is I have to take all these probabilities I just calculated, all these right here, and I just have to put them on a histogram related to the number of hits. So down below here, I'm going to put for my x-axis, number of bullseyes, and I'm probably even going to shrink this a little bit just so I have a little bit of space while I move this. That really tiny. There we go. And I'm going to put all my possibilities here, because I have, let's see, 0, 1, 2, 3, 4, 5, and 6. And I want a y-axis, but for what I'm doing, I don't need to make it super accurate. So for my y-axis is going to be my probability. And let's see, my probabilities go up to about 0.4. So I'm just going to ballpark it. 0.2. Then put 0.3 in the middle here. And then 0.1 here. So what I'm doing is I'm graphing the probabilities of these things happening. Now, probability of getting 0 is very low. So I'm going to make it very low, like right around here. Probability of getting 1, that's still very low. Maybe slightly higher, but still very low. Probability of getting 2, well, it's a little higher, but still pretty low. Now, once I get to 3, things start to pick up a bit. I'm getting pretty close to 1 right here. So I can do that. Now, my probability for 4, that's going to get pretty big. So that's when my axis starts getting a bit bigger here. So I'm looking at about, for 4, 2, 5, so I could get like right around here, somewhere in that ballpark. Now for 5, this is when it gets really big. It's almost up to 0.4. There you go. And then 0.6, and then for 6, probability of hitting it 6 times, it's going to be a bit lower, but just slightly higher than 4. So that is your, what they call the probability distribution function tables and histograms. It just shows you the probabilities of things happening given that number of trials. So as you can see here, the probability of me hitting that bullseye 5 times, or rather this Olympic archer hitting it 5 times, is higher than all the other probabilities. That means the probability of it happening 0 times, 1 times, 2 times, even 3 times are all very low. Chances are, if I'm really, or this Olympic archer is really this good, they should be hitting it about 5 times out of 6. So that's all you're doing right here. You're just calculating its probabilities and making a histogram out of it. So there you go. That is a probability distribution function. Just shows how these probabilities are distributed. And of course, when you add them all up, you should be getting an answer of 1 or very close to it, depending on your rounding. Hopefully this helps you with this. And if you have any questions, don't hesitate to reach out to me. Take care, guys.